week's episode, we went over how to create a raindrop effect. And in this week's episode, we're going to talk about rain drips, or rivulets running down the sides of things. As you can see from the reference footage that I shot, when it's raining, water drips down the sides of objects, like you can see here on my car. And so today we're going to create this effect using the math in a shader. The first thing that I want to do is show you how I created the texture that we're going to use for this effect. So here we are in Photoshop, and the first thing that I did to create my texture is I painted a bunch of drip lines. So I just took my brush and I created these lines and just made them kind of wiggly. And these are the paths that my water droplets are going to be following as they go down the side of the surface. And then the next thing that I did is I blurred my drip lines just a little bit so that I could get a nice fall off on the edges. And then I used this as a height map and converted it to a normal map using the NVIDIA Photoshop plugin. So what that gave me is, first I adjusted the levels of them just a little bit. Then I created my normals, which look like this. And then the last thing that I did is I created lanes for my drips to stay in. And then in each of the lanes, I painted a mask that looks like this. So each of these lanes, let's just change the blend mode to overlay so that you can see what this is doing. So each of these lanes has a different shade of gray. And this gray shade is going to act as a temporal offset so that each lane takes place in a different time segment. Without this mask, all of my drips would happen at the same time, and we definitely don't want that. Okay, so then I took these individual maps, my temporal offset map and my normal map and my drips mask, and I combined them into a single texture. So here's my texture, and I called it rain drips. And if we take a look at the channels, you can see that I have my normal map in my red and my green channel. That's the X and the Y of the normal. Then in the blue channel, I have my mask for where the drips are going to happen. And in the alpha channel, I have my temporal offset mask. Okay, let's switch over to Unreal and get started with the shader. So here we are in Unreal, and you can see that I have my texture just plugged directly into the base color socket of my root node. And I'm projecting it onto my cube using UV coordinates. And for the final effect, I don't want to use UV coordinates. I actually want to project these in world space so that no matter how big the object is and no matter where it goes or how it rotates, these rivulets will always stay oriented up and down, projecting in world space. Now this is a really valuable thing to learn, how to do world space projection, and it's not something that you just can use for this particular effect, but you can do world space projection and use it for all kinds of other things as well. So the first thing that I need to do is bring in a world position node, and so I'm just going to type world and lay down my world position. So I get this node called absolute world position. And then I'm going to scale it by a couple of things. Before I do that, let's just see what happens if I take a couple of components of this world position and use those as my texture coordinates. So here's a component mask. And, texture coordinates are just U and V. So I just need 2 out of the 3 components of world position. So world position has X, Y, and Z, or RGB, and I'm just going to take the R and the B. So that's going to be my X and my Z, and I'm going to use those as the UV coordinates for my texture. Let's just take a look and see what we get. Okay, so you can tell right away that this is not working exactly how I need it to. And so I need to make some adjustments. I actually need to multiply my world position by kind of a small number to get the scale correct. So I'm going to add a multiply. And I'm going to multiply my world position by a scalar. In this case, I'm going to use a constant vec3 so that I can multiply my world position by different values for the x, the y, and the z. And I've done this before, so I happen to know that the values that I want are 0.003, negative 0.003, and 0.0015. So I'm going to multiply my coordinates by that. And then just let's take a look and see what we get. Okay, so I've got a projection, and it's happening here, kind of projecting in this direction on the y-axis, and you can see that I'm getting these really weird stretching happening here on the other side. So I'm just projecting from the front right now, or from the side, and I want to project from the front as well. So typically when people would do this, they might sample two different textures and blend them together. But I'm not going to do that because I want this effect to be as efficient as possible, and I only want to do one single texture sample. And so I'm actually going to blend my texture coordinates together. I'm going to generate texture coordinates for the front and for the side, and then I'm going to blend that together and then sample my texture. So let's go ahead and do that. I need to multiply my world position again. And this time I'm going to multiply it by negative 0.03 and negative 0.03 and negative 0.0015. So this is going to be my second projection here. And then I'm going to do two different lerps. So I need to add a linear interpolate node, and I'm going to add two of those. So I'll just copy and paste. Then I'm going to take this multiply and wire it into the B of my first lerp, and I'm going to wire it into the A of my second lerp. And I'm going to take this multiply and wire it into the A of my first lerp and the B of my second lerp. So I'm blending between the two different coordinates. And now I need to create a couple of masks based on which direction the surface is facing. So I'm going to add a vertex normal node. And then I'm going to take the sine of the vertex normal. And what sine does is if the normal is negative, it's going to return -1, and if it's positive, it's going to return +1. So because it could be negative or positive, I'm going to go ahead and saturate the result, which will clamp it between 0 and 1. And this is going to give me a mask for which direction my surface is facing. And now I want the red channel of this, so I'm going to make a component mask for red, and I'm going to make a component mask for green. So my red component mask looks like this. You can see it's only white in the X direction here. And my green component mask looks like this. So it's only going to be white in this direction here. So now I can use these to blend between my two different sets of coordinates. So I'm going to take the red component mask and blend it with this one. And I'm going to take the green component mask and blend it with this one. So I've got these two different sets of UV coordinates that I'm blending between depending on which direction my surface is facing. Okay, and I've got my coordinates for red and blue here. And from this second lerp, I'm going to want to take my coordinates from my green and blue. So I've got a set of coordinates for the front, and I've got a set of coordinates from the side. And now I want to blend between the two of these based on which it is. Is it the front or is it the side? So I'm going to wire this into A and this into B of my lerp. And now I'm going to create another mask using my vertex normal. I'm going to take the absolute value of my vertex normal, and then I'm going to round it so that I know for sure it's going to be 0 and 1. And then I'm going to take the red component of that. And this is going to be my mask that determines whether I'm looking from the front or from the side. And then I'm going to blend those two sets of UV coordinates using my front or side mask. And wire that into my texture. And now what you'll see, if I connect my texture up here, is that I'm projecting, whoops, got a little bit of a mistake here. I want to grab the green and blue, not the blue and the alpha. There we go. Now what you'll see is that I'm projecting the texture from the front and also from the side. And if we take a look at this on a sphere, you'll see that there's a seam down the middle where it's not blending very well when it switches from front to side. But that doesn't matter in this case because these are rivulets and you're not going to see that seam very well. So this is a really efficient way of blending from both the front and the side and doing only a single texture lookup, because I'm actually blending between my front UV coordinates and my side UV coordinates and then using that to look up the texture. Okay, the next thing that we need is an animated mask that flows down the rivulets as time passes. So let's set that up next. The first thing that we need is a texture for our animated mask. So I'm going to add a new texture node here. And I've created a texture that is 4 pixels by 512 pixels. And I'm just going to drop this down. We're going to find it. It's called a raindrop mask. So here's my rain drip mask texture, and let's just take a look at what this texture looks like. So it's just a long, thin, 4 pixels wide by 512 pixels tall. And I'm just going to take a look at the red channel. So I'm going to turn these other channels off, and you can see it's black here at the top, and then there's this little solid white drip portion. And then it goes to gray and kind of falls off to black. So this is going to act as the mask for my drips. So I'm going to bring in this texture, and we need to create some texture coordinates for this drip mask. Okay, so what I'm going to do is I'm going to bring in the absolute world position again. And I'm going to multiply that by a value and then mask, and we're going to use the R and the B, so we need another component mask here. Using a lot of those in this episode. And so I'm going to use the R and the B of my world position, and we're going to use those as the texture coordinates for the drip mask. So let's take a look and see what happens if we just use this so far. So you can see if I zoom in really close here, this pattern is repeated over and over and over again, and there's a million of them. So we need to multiply our world position by kind of a small value to get to this to the scale that we need again. So I'm going to multiply by a vec3. Let's create a constant vec3, and I'm going to use the value of 0.01, 0.01 and 0.005 to scale my world space position so that it's the correct size for the projection that I want to do. So now you can see that I have this mask and I have my little drip edge, and then it falls off to black. And now I need to do a bunch of different things to this. I need to animate it first of all, and then I need to split it up into the various channels so that it works correctly for my drops. So as always, when we want to animate something, we need to add time. So I'm going to add a time node here. And let's see what happens if we just add this directly to our mask. So here we have our mask. I'm going to put down an add node and wire time into that. So we're just adding time to our mask, and let's take a look at what we get. Okay, so you see we got some scrolling movement here. Now if we were to just use it like this, all of our drips would happen at the same time, and all of the lanes would be in sync. So we want to use our lane mask, our temporal offset mask, to help us get a little bit better results. So I'm going to move this bit of our graph over just a little bit so we have some more space to work. And now I'm going to take the alpha channel of our projected drips texture, which is our temporal offset mask, and I'm going to add that to time. So here's my time node. I'm going to add an add node, and then we're going to take the alpha channel of this, which is our temporal offset, and then we're going to add that to our world space projection, and let's take a look and see what we get. Alright, so that's pretty cool. Now you can see I have the various channels going, and that's working really well. Well, let's go a little bit further. We want to create a differentiation so that we can set up the ability to do slow-moving drips if our surface is permeable. So if it's cloth or stone or something where the water is soaking in as it goes, we want the drips to go slowly. But if the surface is impermeable, like metal or glass, we want the drips to go a little bit faster. So let's set up something that will allow us to do that. So I'm going to add a lerp node. And we're going to multiply our time by this lerp. And now I'm going to add a split component. And I'm going to wire the green and the blue into our lerp. Now we're going to take the temporal offset map and use that again for the alpha of this lerp. Just going to clean up my graph here a little bit. Now I'm going to round. So my blue channel of my texture here is the mask that determines where the drips are happening. And I'm going to round that so I get only 0 or 1. And then I'm going to add, or I'm going to append a couple of things to it. So I'm going to add a constant vec2 and add in a couple of hard-coded values here. This is going to be 0.2, and this is going to be 0.75. And these are the values of the speed of the scrolling. So this is where the drip is happening, and this is how fast it's happening. And I'm going to wire that into my split component. And so here you can see that I'm blending between 0.2 and 0.75 with this lerp. And now I'm going to pass that in and add that to my UV coordinates, and let's take a look and see what we get. Okay, this is something that I want to ask you guys about. Our time node gives us time that's a really, really high value. And if we use this super high value, we lose a lot of precision. And so you end up with this really weird kind of model-y, noisy pattern. And I can fix that if I come here into time and I add a period, which means that my time is going to reset after 30. So it's going to go from 0 to 30 and then reset back to 0. And if I do that, it cleans up a lot of the noisiness because I get more precision. And the lower the value that I give it here, the sharper or cleaner that it is, because I'm limiting my time period to something between 0 and 5. And I really like that result. But the problem is, if I limit it, every time it hits 5, it resets to 0, and I get this little click. So I need to have the period here so that I can have the precision, but it also introduces this little weird anomaly where it's popping and repeating itself. So if you know of a way to use the time node without this period add, but keeping the precision that I need, I'd love to hear about that in the comments down below. For now, I'm just going to leave this here with a period of, let's say, something like 30. Okay, so now you can see I've got my channels and they're scrolling, and I can use this as my mask. And the last thing that I need to do is, once I've sampled my texture over here, I need to multiply the result of that by my blue channel. And so I'm going to come here and I'm going to add a multiply. Then I'm going to multiply that by the result that I'm getting here from the red channel, and we'll take a look and see what we get from that. All right, so now we've got some cool looking little drops. We've created this nice mask, and I'm just going to spend a minute and clean up my graph a bit here so that things are a little bit more organized. All right, there are a couple of more things that I want to do. Like I said, I want the ability to have fast-moving drops on smooth, impermeable surfaces and slow-moving drops on permeable, porous surfaces. So I'm going to take this little block here and duplicate it. And this is going to be what I use for my slow-moving drops. And so I need to change the values that I'm using here. Instead of 0.02, I'm going to use 0.03. And then here, instead of 0.75, I'm going to use 0.0125. And then I need to blend between these two values. I need to add another lerp node. And I need to blend between these two based on how permeable my surface is. So eventually, I'm going to take all of these nodes and put them into a shader function, and the input that I add right here will be how permeable or impermeable the surface is. But right now, I can just type in a hard-coded value. If I use 1, you can see that my drips are going to move really slowly. And if I use 0, you can see that my drips are going to kind of go quickly down the surface. So these are the values that I'm using for smooth, impermeable surfaces, and these are the values that I'm using for rough, porous surfaces. Okay, we're almost done, but there's just a couple of more things that I need to do. So far, I've succeeded in creating a really nice mask for my drips. But what I really want to do is create normals. And so in order to create normals, I need to use the red and the green channel. So I'm going to add another component mask. And we're going to use red and green coming out of my sampled texture. And then in order to make it into a normal, I need to multiply by 2 and subtract 1. So here I'm going to multiply by 2 and subtract 1. And this is almost ready to be my normal. And so I can take this normal and I can multiply it by my mask. So in the areas where actually, let's take a look at what I get if I make this my normal first. So I'm going to add an append because this is just a 2-component vector. I need it to be a 3-component vector, so I'm going to append a constant of 1. So now I have a float 3 here, which is the normal. So now I can plug this into my normal socket, and we'll just take a look and see what I get here. And I should get, yeah, so here you can see the normals. These are the channels where my drips are going to go. But what I need to do is use my mask to determine how bumpy or how intense the normal is. And so before I do this append, I can multiply this X and Y of the normal by this mask that I've created. So I'm going to add a multiply. And I'm going to multiply it by my drip mask and then append the result. And now we're going to see some animated drips. Dun dun dun. Beautiful. Yeah, so this is what we were looking for. This is the effect that we were going for. And there are just 2 more things that we need to do. The first thing that we need to do, if I take a look at this on a sphere, you can see that the tops of the drips are going to look really weird. And so the first thing that we need to do is make a mask that gets rid of this effect on the tops of things. So I'm going to add a vertex normal. I'm just going to take the blue channel of the vertex normal because this is the up vector. And I'm going to take the absolute value of that. And let me show you what this mask looks like. If I plug this into my base color, you can see that this is going to give me a mask that's white on the top and the bottom. I need to adjust the mask a little bit, so I'm going to add a lerp. And I'm going to adjust my mask so that my values are 3.5 and negative 1.5. And this is going to invert my mask, and then I'm going to saturate it to clamp it between 0 and 1. So let's take a look at what this mask looks like. Yeah, so now you can see I've got black on the top and black on the bottom and white on the sides. And that's the mask that we want. So we want our effect to only show up on the sides where the drips are coming down the sides and not show up on the top and the bottom. So I'm going to add another multiply node, and I'm going to multiply my mask by this side mask that I've created. And we'll take a look at what our drip mask looks like now with that. So you can see it's not showing up on the top and it's not showing up on the bottom, but it is showing up on the sides because of this mask that we created here. Alright, so that's pretty much the effect that we're going for. There is one more thing that I want to do, and that is I can use this drip mask that I've created to also determine the roughness or smoothness of the surface. So, but in order to do that, in order for it to be the roughness, I need to do a 1-. And I can wire that in to my roughness. And then that'll kind of get us what we want, but we want to alter that just a little bit. So I'm going to add a power node. And we're going to raise it to the power of 0.5 just to adjust the contrast of it just a little bit. Alright, cool. So now we have animated raindrops going down the sides of the surface. Let's switch over to a cube so we can get a little bit better look. Got our animated raindrops going down the sides. And like I said, in the previous episode, we talked about the raindrops happening on the top. This episode, we went over how to do the rain drips going down the sides. And in a future episode, we're going to talk about how to put both of these together to get drops and drips. But before we do that, we're going to talk about puddles. So next week's episode, we're going to talk about how to create rain ripples in puddles. And that's going to be pretty cool. So if you don't want to miss it, be sure to subscribe and hit the notification bell so you'll know as soon as I release a new video. I'm going to try to get these out every Thursday. Right now we're in the middle of this series on creating weather rain effects. So for the next couple of weeks, we're going to be going over all these different rain effects. In the last episode in this series, we're going to talk about how to put all of those together. So I hope you've enjoyed this video, and we'll see you next week.